I will come. Okay, next topic. Okay, VLSI design. In the first unit, okay, it is topics are introduction to IC technologies. In the topics, MOS, PMOS, NMOS, CMOS, and BiCMOS technologies. Okay, here MOS is metal oxide semiconductor, and PMOS is P channel MOSFET, N channel MOSFET like this. These are all transistors. Okay, and here IC technology means okay integrated circuit technology. Here oxidation, lithography, diffusion, ion implantation, metallization, encapsulation, probe testing. These are all the fabrication process steps. Okay, these are all fabrication. Okay, broadly main steps. Okay, in this we will okay go through all these step by step in the further classes. Here, next acronym of VLSI. Okay, VLSI full form is very large scale integration or very large scale integrated circuits. Now this evolution of VLSI, okay, uh, you will see the graph like this. Okay, in the 1947, okay, first bipolar transistor was invented in the Bell laboratories. Okay, after invention of this transistor, okay, there was a great change in the electronic industry. There was a revolution. Okay, after that, the 1960 first MOSFET was invented, and before that 1958 first integrated circuit, okay, fabricated. Then CMOS. After that 1970s, using this technology ICs, okay, 1968 DRAM was implemented. Then 1971 first microprocessor fabricated. Then after 1980, then VLSI era was came. Okay, like this because of the invention of the IC, okay, integrated circuit, the transistors number of transistors in the single chip was increased. Okay, because of that, uh, size of the ICs was also reduced. Now, if you see your graph, okay, here if you see graph, okay, here you can see here and okay here we have three okay three graphs are there. Okay, first one is here. If you see here, transistor for chip and channel length, supply voltage. Okay, if you see here, transistor, transistor per chip, channel length, supply voltage, and here this y-axis, channel length, supply voltage, transistor chip. Okay, here from 1995 to 2007, if we see here, supply voltage is reducing. Okay, here supply voltage is reducing. Means in the 1995, 3.3 volts used, 98 2.5. When years are increasing, okay, supply voltage, power is consumption is reduced. And same way, uh, channel length 0.28 here, next 0.25, okay, 98 2001 0.18, 2004 0.13, okay, here channel size is reducing. And this graph, if you see, 1995, okay, 12 million transistor for the chip, integrated circuit. Okay, 12 million transistors on the single chip. When years are increasing, okay, this is become 2004 350 million transistors, 2007, okay, 350 million transistors. Like this, go on increasing. Now, the 2015, 2020, that number is more. Okay, because of this invention of the integrated circuit, okay, the number of transistors on the chip increasing. Here also, if you see, okay, here also, if you see, uh, number of transistor per chip increasing, and here, okay, here microprocessor Intel Pentium P5, 3.2 million devices in 93, and the 96 P6, okay, Pentium P6 processors like this, the technology is increasing because of IC technology. Mm. Okay, here uh, now we will see what is integrated circuit. Okay, what is integrated circuit? Okay, integrated circuit is a miniaturized low cost electronic circuit consisting of active and passive components fabricated together on a single silicon substrate. Okay, here active and passive components. Okay, what are the active components? Okay, transistor, diode. Okay, these are all active components. And what are the passive components? Resistors, capacitors, inductors. These are the passive components. Okay, these active and passive components are housed together on a single substrate, single silicon substrate. Okay, that is called IC. Okay, integration of active and passive components on a single chip, single substrate is called integrated circuits. So if you see this diagram, okay, here IC, okay, this IC, see this IC, okay, this is after manufacturing, okay, this is complete IC. Now, okay, if you see here, this one, okay, this is the silicon chip, small silicon chip, and these are all the, okay, these are all the interconnection, okay, connecting wires. These are all connecting wires, and these are all terminal pins. Okay, this is the actual chip area. This is the actual chip area. Okay, this is silicon chip. After these interconnections and after these terminal pins, okay, there is a casing. Okay, this is called casing. Okay, after casing is completed, you can see the complete IC like this. Okay, chip size is like this much only. Okay, this is for casing. Okay, now Here, okay, how these ICs are fabricated, we will see. How these ICs are fabricated, we will see. Okay, here, first step, if we see this one, ingot, uh, this is formed by the, generally, I told substrate, na, the substrate is, we can call it as a wafer or base. We can call it as a base. Okay, these wafers or substrate are, generally we will use silicon. Okay, silicon means these are all semiconductor materials. Okay, silicon, germanium, gallium arsenide, these are all the semiconductor materials. Here, silicon is, okay, it is vastly available and it has many advantages compared to germanium, other semiconductor materials. That's why we will use silicon as a, silicon we will use, okay, in the all wafers. Okay, for the making of these wafers we will use silicon. Okay, this silicon is, okay, formed like a ingot process. Okay, if you see here, ingot means here single crystal silicon, we call it as a single crystal silicon. And this one is, okay, fabricated using the ingot process. And the this structure is like this, single crystal silicon structure is like this. After forming this one, uh, okay, slice, it is cutted. Okay, from this there are different slices are removed. Okay, here if we see, okay, different slice, round size shaped slices are taken from this, okay, this structure. And, okay, very thin size like this wafer, these are all wafers. Okay, and after this wafer is formed, okay, there are 20 to 30 steps are there. Okay, process steps, and some patterns are applied here. Means, okay, patterns means very small size patterns are, okay, used here. Okay, using that small die size, okay, patterns are applied and they can be tested. Okay, after this, okay, patterns are formed and these dies are formed. Okay, here this wafer structure will be like this, and here die separation. Okay, here each die is separated, each die is separated. Okay, and that after die is separation, bonding and packaging is applied. Okay, these are all called die, means single silicon wafer, small size. Okay, in that small size, okay, device fabrication will be done in that small chip. Okay, the major advantage of the IC over discrete component based circuits are, what are the discrete components? General we will use resistors, capacitors, transistors, all on the, okay, general circuit. We'll call it as a discrete circuit. Okay, here whereas ICs, all components, active and passive components are, okay, housed in the single silicon wafer or substrate. Okay, because of that, the advantages are smaller physical size, okay, higher speed, low power consumption, okay, reduced cost. Okay. Now, why integrated circuits? Okay. Why we are using integrated circuits? Because very small size miniaturization and hence increased equipment density. Here, what is density? Means because of okay small size, the number of transistors are more. And suppose in the chip, if we apply 100 transistors, and after integration, okay, using integrated circuit technology, okay, if we apply okay 1,000 transistors in the chip, okay, automatically the density of the equipment increases. Okay, are you able to listen? Okay, okay, instead of forming 100 transistors in the chip, okay, if we apply 1,000 or 10,000 transistors, the density of the IC is increases, equipment increases. Okay, because of this miniaturization and hence increased equipment density. Okay, because of very small size, the equipment density increases. And batch processing. Second one is batch processing. Okay, here okay, batch by batch. Somebody mute your audio. Okay, here batch processing. Here what is batch processing? I am fabricating okay 1,000 transistors at a time. Okay, 1,000 transistors at a time. Yes. Okay, I am fabricating 1,000 transistors at a time, and okay, instead of fabricating 1,000 transistors, okay, I can fabricate 10,000 transistors at a time. Means okay, batch by batch. Okay, batch by batch, I can fabricate these transistors. Okay, because of that batch by batch fabrication, we can reduce the cost of the equipment. Okay, that is batch processing resulting in cost reduction. Next, improved system reliability due to the elimination of solder joints. Okay, because here in the ICs, okay, we won't use any soldering joints. Okay, this is formed by the IC fabrication. It is formed by the layer by layer. Okay, layer by layer fabrication. Okay, here reliability also improved, and we won't use any soldering joints. Okay, in the discrete circuits, okay, resistors, capacitors will use soldering joints. Okay, but in the ICs, okay, soldering joints also not there. So, and system reliability increases. And fourth point is better functional performance. Better functional performance means because of very small size and speed of the these ICs also increases, and their functions also improve. And fifth point, matched devices. Okay, using IC technology, we can fabricate similar devices. Okay, matched devices. Okay, because of IC technology. Next, increased operating speed. Okay, because of the uh, okay, identical devices and small size. Okay, operating speed also increases. Next, significant reduction in the power consumption. Okay, because of lower sizes, device also uses less power. Okay, that will give power consumption very less. Okay, using this IC technology. Okay, in the suppose if you want to turn on the system, okay, it will turn on in 5 seconds. Okay, it will turn on in 5 seconds. Okay, other system it will turn on in 20 seconds. Okay, which system we want? We want 5 seconds to turn on the system. Okay, that we want to, okay, desire to have that, okay, lower operating speeds. Okay, next, ICs can be classified on the basis of their chip size as given below. Okay, these ICs can be classified basically, okay, three categories based on their, okay, application or, okay, fabrication or size. Okay, ICs are basically classified into three categories. Okay, based on the application, fabrication and size. Okay, based on the size, chip size. Okay, these ICs can be classified into, okay, four categories. Okay, small scale integration or SSI. Okay, in this we can use 3 to 30 gates per chip. Okay, small scale integration SSI. The medium scale integration MSI. Okay, you will use 130 to 300 gates per chip. And here, when years are increasing, this technology was developed. Okay, in the MSI technology, 130 to 300 gates per chip. In the LSI, large scale integrated circuits, okay, 300 to 3000 gates per chip. Next, last one is very large scale integration, VLSI here, more than 3000 gates per chip. Okay, next technology is also there, that is ultra large scale integrated integration. Okay, ULSI. Okay, if you see here, okay, evaluation of integration level in integrated circuits. If you see here, uh, here 1958 single transistor, okay, number of transistors for chip 1, and 1960, okay, monolithic IC 1 to 2. When years are increasing, technology increased. Okay, here number of transistors 100 to 10,000. VLSI 10,000 to, okay, 1 lakh transistors, means here more than 10,000. Here ultra large scale integration, okay, 1 lakh to more than 1 lakh transistors. Okay, these are all the evolution of the IC. Okay, now if you see, these are the different types of ICs. Okay, different types of ICs. Okay, this is metal can IC. If you see here, metal can IC. This is ceramic flat pack IC. Okay, these are all ICs. Ceramic flat pack IC. And this is dual inline package IC. Okay, generally we saw in the labs. Dual inline package. This is 14 pin. Okay, here also this is dual in line package IC. Okay, here 8 pin. Okay, if we see here internal structure, okay, this is the chip. That is chip, and okay, these are all interconnections. Interconnection. These are all terminal pins. Okay, this upon this structure is the casing. Casing of the IC. Okay, that is ceramic casing or some plastic casings are applied. Okay, this is so here this is IC. Okay, you can call it may be processor IC. Okay, these processor ICs are very big, and these are all small ICs. Okay, IC. Okay, this for different functions we have different ICs. Okay, different ICs. Uh, yes, I already told. Okay, these types of integrated circuits are based on the fabrication. Okay, basis of application, basis of scale or level of integration, or based on the size, scale or level of integration. Okay, on the basis of fabrication. Okay, these are monolithic ICs, hybrid ICs are there. So, and based on the application, based on the application. Okay, analog ICs and digital ICs. Analog ICs means linear ICs. Okay, this is based on the application. Okay, based on the application, these ICs are classified into analog ICs, digital ICs. Okay, it is also called linear ICs. And here digital ICs, okay, generally we will use in computers and logic circuits. These analog ICs or linear ICs we will use in op amps. Okay, here the ICs relationship between the input and output of the circuit is linear. Okay, that's why you are calling it as a linear ICs. The digital, okay, circuit either in on state or off state. Okay, here digital on state or off state, or 0 or 1. Okay, this is this is based on the fabrication. Okay, based on the fabrication, ICs are classified into monolithic ICs and hybrid ICs. Okay, here monolithic ICs. The monolithic ICs, word monolithic comes from the Greek word monos and lithos. Okay, monolithic means monoth and lithos means mono means single, lithos means stone, means single stone. Okay, using single stone we can fabricate the transistors. Okay, that's why you're calling it a monolithic IC. Means single crystal or single stone we will use. Okay, monolithic ICs refer to a single stone or a single crystal. Okay, in that single stone or substrate we can build the transistors. This single crystal refers to a single silicon chip as the semiconductor material, on top of which the passive and active components are interconnected. Means active and passive components are okay built on the this single stone or single crystal silicon. Okay, now what are the advantages of this monolithic ICs? Monolithic ICs are considered as the best mode of manufacturing ICs. Okay, because it can be made identical ICs, high reliability, manufacture in bulk in very less time. Okay, using in given very less time we can manufacture more number of ICs. Okay, low cost. Okay, these are the advantages of monolithic ICs. Now, here what are the limitations? Okay, for every chip there are some limitations.